Okay, so in this problem, I'm going to ask you to provide a product and a mechanism. So again, mechanism is SN1, SN2, E1, E2. You can see the after image from the last problem there. So again, you really need to sort of break this down. Do you have a leaving group? That's the first thing on the flow chart. You do, it's a bromide. Do you have a strong base or a good nucleophile? In fact, you have both. So sodium methoxide is a strong base. That sodium is a +1. The methoxide is a -1. So that oxygen has a localized negative charge on it. It's a strong base. Now, a word of caution. A lot of times people, you guys are reading the book, you're trying to memorize all this information. You've probably figured out that a higher temperature favors elimination, a lower temperature favors substitution. You've probably figured out that a polar protic solvent favors SN1E1, whereas a polar aprotic solvent favors SN2 and E2. So methanol is polar protic. Low temperature, really anything below 40 degrees, favors substitution. The caution is, both of the things I've just said are true. The caution is, those are the last things you should consider. Work through the flow chart first. Do you have a strong base? Do you have a leaving group? Yes. Do you have beta hydrogens? Yes. Do you have a good nucleophile or a strong base? Yes. Those take you to the SN2, E2 part of the component of the flow chart. These things come in only if you're trying to break ties at the end of the flow chart. So consider these last. Okay. All right. So I'm going to hit pause. I'm going to hit pause and I'm going to erase some of this writing I've got on there. Study that. Go away. Try to tell me what the product will be and what the mechanism is. I don't have to hit pause there. Okay, you're back. There are a couple of beta hydrogens, a couple of different chemically distinct. There's a beta hydrogen here, so the alpha carbon is the carbon of the leaving group. Beta carbon is any carbon bonded to that. So that hydrogen is beta carbon, or beta hydrogen. That hydrogen, and there are 3 of them, are beta hydrogens. So if we just do the elimination, so the possible elimination products are these. If we do substitution, if we substitute methoxide for bromide, we would get that. Those are basically the 3 products we can get out of this reaction. Okay, so how to determine which one is right. So again, leaving group, yes. Beta hydrogens, yes. Strong base or good nucleophile, yes. Leaving group tells us we can do substitution or elimination. Beta hydrogen tells us we can do elimination. Strong base or good nucleophile. If we have that, it will be E2 or SN2. We don't even have to look at the substrate quite yet. Okay? So we're going to do an E2 or an SN2 because we have a strong base. Methoxide is both a strong base and a good nucleophile. So what about the leaving group? You'll notice that this leaving group is on a tertiary carbon. Okay? So the carbon the leaving group's on is bonded to 3 other non-proton things. So 3 carbons in this case. Makes the environment around that carbon very sterically hindered. So it's hard for the nucleophile to get in here to kick out the leaving group. If this is the case, therefore no SN2. We can't do an SN2 reaction. Okay, you have a strong base, good nucleophile. You can't do SN2. So that means you're going to do E2. So we eliminate the substitution product and we're left with the 2 elimination products. And then choosing between these, The double bond in both cases is conjugated to the benzene ring, so it's fairly stable. This is tetrasubstituted, that's disubstituted. So the tetrasubstituted alkene will be the major product. You'll see a little bit of the disubstituted. All right, and this is from an E2 reaction.